Yeah, hello everyone. My name is Lucas. Today I want to talk a little bit about ArangoDB. One thing that I noticed during this conference was that a lot of the talks were about thinking differently about problems or solving them differently. There were some talks about NoSQL databases that where you don't have to store things in tables and think about them differently. So I want to continue that trend. But first, a few words about myself. So I'm from Cologne in Germany. I lived there. I was born there. It was a long flight here, but I didn't have the bad luck to be stuck by Lufthansa strike. So I arrived here, and I really like it here. I work in the ArangoDB core team at the company that builds ArangoDB. And in this job, I mainly work on two things, ArangoDB Fox, which probably doesn't tell you a lot, but I will talk about that a little later. The tiny fox there is the logo of ArangoDB Fox. And then I do a lot of Ruby stuff, the Ruby driver and other things for the Ruby community that wants to use ArangoDB. Otherwise, I'm an open source developer on different projects. I'm a podcaster, but this is in German, sorry. And I also organize our local Coder Dojo. If you want to talk about Coder Dojos and teaching kids how to program, please come to me. I always love to talk about it and help you get started if you want to do that in your city. Also, I don't speak Spanish at all. I feel a little bit bad about it, like going to a restaurant and not understanding anything what the waiter is asking me. And I will start again learning it with Duolingo, so I'm better next year. And I want to thank the interpreters. Thank you so much, because otherwise I wouldn't understand anything of your talks. Okay, enough about me and interpreters. Let's talk about ArangoDB. So ArangoDB is open source and free. It is a multi-model database. What that means I will talk about in a little later. Like, this is the concept of my talk, basically. So then I will talk about the query language of ArangoDB AQL, how you can extend the database using JavaScript. How many people are here that hate JavaScript? Oh, really good. Okay, so also I will talk a little bit about replication and sharding, high performance and space efficiency, like every single database probably, a little bit about the admin interface, and then about the Ruby stuff. Okay, so let's get started. Free and open source, what does that mean for us? For us, that is the Apache 2 license, because it gives you a lot of freedom in using the software in the way you like it, in your commercial environment, extend it, do whatever you want with it. It's on GitHub. You can even fork it and create a ArangoDB with 2R, because that's a common miswriting of the database. Then you can make people go to your database instead. You can do whatever you want with it and don't have to pay for it. That's free and open source. So one thing is that NoSQL is not one thing. So a lot of people make statements about NoSQL in general, and I think that's not really possible, because the word NoSQL doesn't have a lot of meaning. For example, a lot of people say NoSQL can't do joins. That is not true. Like ArangoDB, for example, can do joins. Or people say NoSQL databases don't support transactions. That's also not true. Like, for example, ArangoDB supports transactions. If you hear a general statement like that, you should probably doubt that statement, because except for the database doesn't use SQL, it's probably not true, and even that statement is not true. So yeah, it's probably a database. That's everything you can say about it. So there are a lot of different categories of NoSQL. One category is the graph database. We also heard a really good talk about that already at this conference. Data structure servers, that's what I think Redis is, but yeah, there are a lot of different interpretations of what Redis is and what the category is. Some people call it key value store. Yeah, I don't know. Then there are aggregate-oriented databases. I will explain what that means in a minute. And then there are like very specific databases, like time series databases. They are only built for one purpose, to store time series. A friend of mine builds an application with that, where he stores results from load testing and other services, and he uses a time series database because he has to have a lot of time slots where he says, like, this is what happened then, what happened then, and then afterwards he can analyze that. And this is a very specific database, and that is also a strength of the NoSQL thing, because you can find a solution that's very specific to your use case. So aggregate-oriented database. This is a term that Martin Fowler came up with, and if Martin Fowler comes up with a word, it's probably a good word. So I like to use it instead of the other words in that area. And he unites three kinds of databases under this term. And this is the key value store, the document database, and the column store family. And those databases, they have differences, but especially between the key value database and the document database, there is a lot of commonalities, and some of the key value stores have evolved into a document store. So I think this word makes a lot more sense than like cutting it too fine between the different database kinds. So I think an aggregate-oriented database is a database that can store aggregates as one unit. And what is an aggregate? An aggregate is a collection of domain objects that belong together. I will talk a little bit more about domain objects in a few minutes, but that basically means like you have a person and it has an address and it has other stuff that's connected to it, and you want to say that this is one unit, like this all belongs together, and this is an aggregate. And an aggregate-oriented database allows you to store this as one unit, and not forces you to do joins or join tables and stuff like that. ArangoDB is an aggregate-oriented database. It allows you to store documents that have similar logic, logical similarities in one collection. So this is what would be called a table in an SQL database. That doesn't mean that they have to have the same structure. So you can store documents that describe users in one collection, but some users may not have a first name. It's still possible to do that. But as you can imagine, if you store users in your data in your collection, they probably are pretty similar to each other, because even though that your database doesn't force a schema upon you, your application still has a schema. So what we do is we make an automatic schema recognition. So whenever you store something in a collection, we try to see, does it look familiar to another document in this collection? And when it does, then we only point to the schema. And this saves a lot of space if you want to write it to disk and also in memory. And this makes it much more space efficient than the other document databases. Okay, second category, graph database. I would normally insert a long ramble around, graph databases are awesome, they can be used for so many things, but we already heard that, so I can skip that. I think it was an excellent example. I also don't like the social network example because it's misleading people to think that a graph database can only do social networks. I think you can do a lot of things with it because in your program you have an object graph, and an object graph, surprise, is a graph. So you can store that very natively in a graph database. One thing that I came across when working in the university was that I had to create a database for a computer science bibliography where you would say things like find authors that work together with other authors and are similar to other authors, and that lent itself very naturally to a graph database. I had to do it with Oracle, and I had to write a lot of join statements, and I was not very happy about that. ArangoDB is a graph database that supports property graphs. A property graph is a graph where the vertices and the edges both have properties, so you can say things like this has a label published, and it has 99 to 120 pages is the description of this specific article. So what is a multi-model database? A multi-model database is a database that combines different kinds of databases into one. And ArangoDB combines a graph database with an aggregate-oriented database. So that means that we have documents which are the edges of the graph, and we have the nodes of the graph, like the astronaut Alice and the space shuttle. And we also have edges between them, and they are also documents. So whatever you want to do with a document, you can also do with an edge or with a node. And this allows a lot of flexibility. Why is that useful? So this is from Eric Evans' domain-driven design book, which is excellent. You should read it. It has a lot of good advices on how to design and how to come up with a model together with your client. one thing I want to pick out of that book is analyzing your different kinds of domain objects. So what you have, for example, is an entity. An entity is something that has an identity. This is a tongue breaker, but I hope I said it correctly. So an entity is for a person, for example, is an entity. It is like, you can say this is a person, and then the person changes his or her last name because they get married, for example, then it's still the same person. And you don't want to copy that person or something like that. Therefore, you want it to be mutable. So an entity is mutable, and you can say, okay, this is still the same person even though some attributes about that person changed. With a value object, it's different. A value object is only identified by its value. It doesn't have its own identity. So for example, a street address is most of the time a value object. So you can say a street address consists of a street and a house number and a city maybe. And if you change something about that, then it becomes a different address, right? Like if you change the 7 to a 15, then it's a different house, so it's a different address. Therefore, you can say that they are immutable, because as soon as you change it, it would become a different object. And why is that interesting? Because in a multi-model database like ArangoDB, you can say that if you want to connect two entities, then you just add an edge between them. And you say, okay, now those two are connected. If you, however, have a value object and your entity, then you can take that value object and embed it into your object. So that allows you a lot of flexibility. If your database only supports graphs, then you can only add edges. If your database only supports embedding, then you can't do edges between them. And therefore, this gives you a lot of flexibility. To make use of that flexibility, you need a solid query language. So we designed a language called AQL, the Arango query language. One thing that was very important to me as a computer science geek is that it is a relational algebra that gives us a lot of nice properties. And it features things like joins, so things that you are familiar with from the SQL world. This is a very simple example. We iterate over all users, and then we only take those users that have active set to true, and then we return for each of those users only their name. So this would give you an array of objects where each object has a name attribute set to the name of a user that is active. But ArangoDB also features other ways to query. If you have a very simple thing that you want to do, a query by example might be everything you need. For example, this could also be expressed as a query by example by just searching for all users where active is true. You know that maybe from databases like MongoDB, who feature query by example as their way of querying. Then we have graph traversals, because it's a graph database. You want to have a simple way to jump from node to node, and this is a graph traversal, which you can imagine as like a tiny person that runs on your graph, like from node to node. And you tell this little person the rules on how to follow those edges. And this is a graph traversal. And then we have Fox for extending the API. So ArangoDB has an HTTP API, and with the help of Fox, you can extend this API or adapt it to the needs of your application. So why you may want to have a more expressive query language? So there was an article by Sarah May a while ago where she talked about MongoDB and why MongoDB was not a good fit for her database. She expressed it differently. She said you should never use it. I don't agree, but it was not a good fit for her use case. And this was the application she was designing. It is social network, so sorry for that in advance, doing graph talk about a social network. We have a lot of different things going on here, and ArangoDB has the flexibility of doing each of those things in a different way. So for example, we have the comments, and each comment has a person that commented on it, right? That wrote this comment. So if you are an SQL developer, you would probably have a commenter ID, put it into the comment, and then you can do a join later on. And this is also possible in ArangoDB because it has a join. You could also do that in a graph fashion, but in this case, maybe you want to do it with the commenter ID. Then you have something like this, where every post has a lot of comments in it. Then you can do that in a way by embedding it, because the comments, maybe you don't want to show them separately, you only want to show them if you get the list of, if you want to look at one post. And then it makes a lot of sense to embed it, because you can have an array of comments in there, and they are, in this case, a value object. In the case of users that have friends, this is the classical example for a graph database. So you can do that by having the users and the friendships as edges between the users. So another example for how we can do stuff like that in ArangoDB is an aggregation. So in this case, we go over all the users and then collect all users into together that have the same city. So here we return the city and then the number of people living in this city by using the ArangoDB AQL function length. I think that's quite straightforward to read. It is also possible to do graph queries in AQL if you don't want to write an entire traversal, and this would be an example for that. You can see we go over all users, and then we go over all paths in the graph, and we only take those paths that begin that start from the user, and therefore we can then return a user and all the outgoing edges of that user. I said in the beginning that ArangoDB is extendable through JavaScript. So what does that mean? One thing you can use it for is multi-collection transactions. So you can say, execute this JavaScript function as a transaction. If something goes wrong, it will be rolled back. Yeah, like a transaction as you know it from SQL. You can also use it to extend the web API. Why is that interesting? Imagine you have a case where your application, your database have to talk back and forth because you have to do some calculations in the middle and then do another query and stuff like that. If you can do that inside of your database, then you can only send one single request and get one response back, no back and forth between those two entities. You can also use that if it would be a very data-intensive operation, then you can do all of that in your database and only get like the very important result from that operation back. It is also possible to write your individual graph traversals, like I said, this tiny person that runs around on your graph in JavaScript. So this is why this is useful. So HTTP APIs, I think I don't have to explain why they are useful. You can use them if you want to build a single page web application or a native mobile application, or you want to allow other developers to access your application. All those cases are very good for a HTTP API. And ArangoDB already has an HTTP API. So one day I had this idea that what if we let the single page web application or the mobile app or the developers talk to the database directly. And everyone looked at me like, are you crazy? That doesn't make any sense. This is insecure and people can destroy everything. And I agreed. But I came up with the idea that if you can really adapt that API and restrict the access to certain things, then this becomes reasonable. Then you can say, okay, now you cannot drop my tables because this is forbidden. You have to be an admin to do that. Because ArangoDB is written in C and C++ and running a V8 engine inside of it, you can execute JavaScript. So I wrote it in JavaScript, even though I would have preferred to write it in Ruby. But yeah, you take what you have, right? So this is ArangoDB Fox. The you can imagine like a small layer on top of ArangoDB, but it runs inside of ArangoDB. You don't have to install it separately. You can have tiny little applications and all of them install them in ArangoDB. You can make them as small as you want and then compose them as the new API of your database. And then you can use it, for example, to talk with your single page web applications with your database, but also if you have a classical application written in Ruby using Cuba or Lotus or whatever you want, it can talk to this Fox application as well. And why is that really helpful? Because in this case, you can reduce the duplication that you would normally have in this case, because you would have logic that would be both in this application as well as the API thing. So now you can pull that into one area and reduce the duplication, even though you have to write in JavaScript. I was inspired by Sinatra when I wrote Fox. So this is how it looks. You create a controller, and on that controller you can then define routes. For example, a get route on /user/something, and this something is called a name. Then we can make a response by sending a JSON back to the user, where hello is set to the value of this parameter name, and therefore it can greet your users, which is extremely useful. I built it into all my web applications. So Fox has a lot more. Fox has a lot more features. It has full access to all the ArangoDB internals, so it can do simple queries, SQL queries, traversals, and stuff like that. It automatically generates documentation for you. It is MVC style framework where the M part is split into models and repositories, and you can have small applications and share them with other developers because you can upload them to a repository and then people can install them. It features background workers if you want to do stuff like sending an email every time a user signs up or something like that. And it features an authentication module which is central to what I just explained. Like if you want to keep users from doing whatever they want with the database, you probably want authentication, and you can use basic auth and OAuth 2.0 in that case. We can add more, and you can also just make a pull request and add more authentication methods to that. Fox Generator is something I'm working on right now. It was in my master thesis. I'm continuing this work now that I handed my master thesis in. It is the simple idea that if you have a REST API, you could express that as a state machine. And when I say REST, I mean REST in the sense of fielding and not in the sense of DHH. So some people call that hypermedia. I prefer to call it REST because that's what it is. If you're interested in that topic, talk to me. I don't have enough time to explain it, and most people don't care about it. So come to me if you want to talk about it. Replication and sharding, master-slave replication check, sharding check. If you want to learn more about it, get on the website. There's a white paper. There is the entire concept. You can read it and ask questions on our mailing list or stuff like that. Up next is auto failover, which makes a lot of sense if you build sharding already. So brief thing about the high performance space efficiency. So it's really space efficient. We made a lot of comparisons with other document stores like CouchDB or MongoDB, and it saves a lot of space. So in a lot of cases, the space on disk was smaller than if you activate gzip compression in CouchDB, which has implications on the performance of CouchDB, of course, because you're using compression. And this is done by this automatic schema recognition. It is also really fast. I don't think there's any value in giving you some performance measurements because you should do them yourselves because they are specific to your application. Try it out. If you've run into a problem, please talk to us. Maybe we can help you. Maybe we can fix something in our database. Maybe we can help you optimize your queries. I think that's better than giving you some fancy charts. So we also have a quite powerful admin interface. It allows you to manipulate all data, get information about what is happening in the database and stuff like that. My favorite part is this Graph Explorer that a friend of mine built at work. And it allows you to interactively explore the graph that is stored in your graph database. So you say, I want to start at this specific node, and then you can make your way through the graph, like looking at the neighbors, then click on the neighbor, and go through the graph this way. It's really cool. Try it out. I really like it. Okay, some Ruby stuff in the last minute that I have. I now am the official maintainer of the gem Guacamole. I couldn't believe that there was not the Guacamole gem beforehand. So now I have the name Guacamole on Ruby gems. It is a simple, it's a data mapper gem. So if you are familiar with that pattern, it works like that pattern. It separates concerns that fall into one class in active record, which I don't like. So we did it differently in a Guacamole. guacamolegem.org if you want to see some more code, then the little code there will show you in a minute. And underneath it uses the Ashikawa core ArangoDB driver. That is a Ruby driver I wrote that allows you to talk to the database in a very low level terms. So every REST, like every HTTP endpoint is mapped to some Ruby class, and you can imagine how this works. Very simple, very straightforward. So a small example, in the tradition of Guacamole, it always has to have My Little Pony examples. So we have a ponies collection here. It is a Guacamole collection, and inside of that we want to store ponies. So we create a class that is the pony, the pony model, and it has two attributes, the name and the color, and they are both strings. This is powered by Vertis. And then you can define validations on it. We are also thinking about extracting the validations into a separate class. If you have suggestions on that, please talk to me. In this case, we check that the name is always present. So the color is not always, doesn't need to be present. Then we create a new pony, Pinkie Pie, and we save it into the collection. So you see that the pony doesn't know how to save itself. It's just a model. It's just like an object flying around in space. But the collection can then take it and save it into the database. Okay, and that's the Ruby part. Last thing, I have a special announcement. Since like 2 hours, there is something new coming up, RubyConf. So if you want to learn more about it, follow RubyConf on Twitter. It's some mysterious conference that will happen in Uruguay. So yeah, maybe it will be interesting to you. I'm MoonLabs on Twitter. Thank you so much for your attention.
Preguntas, allá al fondo.
Any questions?
Hello.
Hello. Given the fact that I know Redis and I know SQL, when should I use ArangoDB? In which use cases instead of using Redis or Postgres? When is it more efficient or more reliable or easier to use? So why should I learn ArangoDB instead of keeping with Redis or SQL?
Yes. So I think that the strong point of ArangoDB is whenever you have more complex structures where you when you query your data, you have to jump a lot between like entities in your database. Because if you use Postgres, for example, then you have to have recursive joins or join statements that are like nested in one in each other, and this gets really hairy really fast. So in this case, it's more natural to use a graph query, and you still have, compared to a graph database, you still have the power to nest data, which you know from databases like MongoDB, which is very helpful, as I explained in the modeling part.
Here, another one.
Hello.
Hey, how are you? I wonder if does ArangoDB work with the query optimizer, or can we see the execution plan for the query that we wrote on AQL?
Okay, so yeah, we have a query optimizer, and since the last release, you can even look into this query optimizer and see what's happening. And there's a lot of work being put into that, and you can even look into the execution plan if you want to do it on a cluster, for example, execute this on the cluster. If you want to learn more about it, probably ask in the mailing list. The people that implemented that will be happy to answer all questions about it.
Lucas here.
Yes.
Thank you for the talk. It was great.
Thank you.
The traversal functions for the graph includes things like Dijkstra minimal path or functions like that.
Okay, yeah, so the built-in functionality is the shortest path. We have Dijkstra, but we also have A star, which is better for some use cases. Like common neighbors, like like things that I learned in university are like the basic graph algorithms. We support them out of the box. If you need a custom one, write a custom one. And if you say, okay, this is really useful, a lot of people will use that, talk to us, maybe we can just include it in the database.
Hi.
Hi.
I'd like to know if there is a way to import the schema of a MySQL database, the schema and the data of a MySQL database into a graph in ArangoDB.
Okay, so currently you can only import JSON files because we think that this is too specific to your modeling, right? So we cannot say, okay, we'll import a MySQL database because you have to model a little bit different in ArangoDB. It would not make a lot of sense. But if you just like build an export script for your data and export it to JSON, then you can take that JSON and import it into your database, if that helps you. If it's really like a straightforward mapping, that should be easy because then you can take like SQL, like a SQL gem, write JSON data, and then import them.
Última pregunta. No.
Last question? No? Thank you.